In this video, we are going to be looking at how to calibrate for depth, so that by the time we start scanning and we have an indication or a confirmed crack, as the case may be, we will be able to determine the depth of the crack. So what we do basically is to use these three notches. These are known depths: our 0.5 mm and our 1 mm and 2 mm. So it's just doing a basic graph. Even when you use Nortex 600, that basically does not give you the depth. But with this understanding, knowing fully well that I am going to have, this is my impedance curve, I'm going to have 1, 2, 3, which is my impedance curve. You know that this is 0.5, this is 1 mm, and this is 2 mm. If you are even looking at your Nortex 600, you will find out that in your VPP and your and your angle PP, you are going to get values for them. Let's say this is 0.1, whatever, maybe 20, whatever the value. If I get this first one, when I'm passing through this first one, I will get a value for the voltage. When I'm passing through the second one, I'll get the value for the voltage. When I'm passing through the third one, I'll get the value. If we were to plot a graph of voltage versus thickness, we will discover that, say this is 0.5, this is 1, this is 1.5, this is 2. We will discover that at 0.5, we are going to have a specific voltage. At 1 mm, we are going to have definitely a higher voltage. And at 2 mm, we are going to get a much more higher voltage. By the time we draw this, we are going to get a curve. Mathematically, if you are able to determine the equation of this curve and put it into the machine, at any other point other than these three known points, let's say if we have a point that is somewhere here, with the value of the voltage, you should be able to tell the thickness of the indication. So basically, that's what we do for Nortex 600 method, that normally do not give us the thickness of the crack. But when you come to Eddycon C, this automatically is done by the machine, so it's way easier to get the depth. So now we have these three notches. We are going to scan and get. So remember 0.5, 1 mm, 2 mm. So I zero and I balance. So I'm going to get first curve, second curve, third curve, and I search. If I go back position wise, so let's go down to our scan and reduce this. Okay. So we can see the three indication, and we'll go to our width and increase the width a little. So if I come down here, if I come down position wise, if I come down, this is my first indication for 0.5. You can see the voltage, which is 0.059, which is the voltage. By the time I go to 1 mm, you can see the voltage. It has obviously increased 0.7. By the time I go to 2 mm, when you check the voltage, you see that the voltage has substantially increased, 0.92. So with this, we are going to plot on the machine so instead of manually doing it like in the case of the other equipment, this machine will automatically do the calculation and get the curve in the machine. So what do? We we come back to this calibration button. We make use of this calibration button. This is what we use in calibrating. So this is if you look at the screen, you'll see calibration here. So you are calibrating for depth. Now you can use more than 3 points if you have such notch, but we only have 3 for this. So what it expects you to do is this. You are going to highlight it. So curve type A. What are the other options that we have there? We have type P and type A. So type P, we are using the peak amplitude, the voltage of the peak amplitude. Then P to P, we are using type P, we are using the peak to peak. So let me just explain this a little. So if I have a curve that comes like this is the 0 point of the curve. This is the peak point. The change in voltage between these points to this point is the 0 to peak voltage. But let's say I have another indication that came around this area. Between this peak and the other peak, this is one peak, this is second peak. This is our peak to peak voltage in terms of eddy current. But we are just going to take a single peak and we are using an A. Our unit is in mm, and we are not using shim. If we are using a shim, we are going to check on this bus. We are not using shim. So we go to the cursor position now. We go down to the cursor position and we start adjusting the position until ensure that if you look at this, there are 3 lines here: the beginning, the end, and the center. If you want to accurately do it, you can position them such that the center line is at the peak of your indication and the other 2 are at the start and the end point. How do you do that? Is to adjust the width. So I can come down here and adjust the width, reduce it enough to capture those 2 points. So you can see it's at where I want to be. Now, I come down. Take note, I've explained this concept of peak to peak before. If you want to change it, you can change center, peak to peak, center to peak, center to center, the maximum vertical amplitude, and all that. So let's stick with our peak to peak. If you now come down to your first point, this is your first point. We've gotten our first point. We will say enter. What is the thickness of these first points? We come down here. This is the voltage we are seeing here. This is the voltage we are seeing here. If you can see 0.058. And this is our phase angle 179. We've entered the first point. That point has been recorded by the machine. We go next to position and look for the second point. We move. We get to the second point properly centralized. And this is the voltage. If we are sure everything is up to date, we say enter again. Take note, it is you that will come back here and change the value of the thickness from 0.5 to 1 mm. It is the user that will put this. It is the person that the machine automatically will just give you 0.5, 0.5, 0.5, but you need to correct it that this is 1 mm notch. Then after then you go back to position again and you capture the next one. And you say enter again. This time you come down and change it. You change it to 2 mm. And you have calibrated. The machine understands this now. By the time you leave this spot, the calibration has been done. So we can go back to, we can come back here and check to see if our calibration indeed has been done. So I zero again and check. 0.5, 1 mm, 2 mm. Oh, there was a mistake here. I balance again. 0.5 mm, 1 mm, 2 mm. Let me search now and see whether they align. Like this. If I check my position of this, if you look at the thickness, it is giving me something around 2.2. By the time I get to the center, I'll be getting almost 2 mm, which is still within my acceptable limit. If I come down here, I should be seeing something close to 1 mm. I'm getting 1.22. If I come down here, I should see something within the range of 0.5. You see 0.51, 0.56, 0.6. So you discover that your equipment has been calibrated, and that is done.